Yeah, all right. Good morning, good afternoon, good evening, everyone. Welcome to this class. It's been a while since we had a proper class, and I think I'm happy to finally have this particular class because it's a very, very interesting topic, to be honest. And the topic is something that I know that a lot of interviewers would always ask, oh yeah, do you know this particular topic? Do you know how to implement it in that? Do you know how to implement it in Flutter? And the reason for that is because it helps you like kind of like improve how you view your code and how you write code, and it helps you kind of like see your code from a certain lens, right? And that topic is actually called solid principle, right? So solid principle is nothing like it's just an acronym. It's just an acronym of like five um important style of writing, I'll put it that way, or way of writing code. So the way say for instance now the way you live your life, right? There are certain patterns you can do to like improve your own lifestyle, right? There are also certain patterns you can apply to your code that will help you improve how you write your code. So you just see all these principles as more of like a way of life and or a way of writing code rather than something very complicated. So but firstly I want to verify something. Can everyone hear me? Because I know I have a very bad network. Can I get like an emoji? All right, thank you. So yeah, like I mentioned, right, solid is an acronym for five the design principle, or yeah, software design principle. And the very first one, which is S, right? Let me just create like a project for this. So documents, okay, directory. I think I have to zoom in a lot. Okay, make directory. That's my tutorials. I think this works. Silly. So let's create a project. Create solid principles. Principles. All right, so I'm creating a you know, project for like the solid principles so that we can use that to, explain whatever I am talking about, right? And yeah, so we have five solid principles, right? So S stands for single responsibility principle. O stands for open closed principle. L stands for Liskov substitution principle. And then I stands for, interface segregation principle. And then the last one is D, which is dependency inversion principle, right? So let's just navigate into this our project so that I can use this to like explain whatever I'm saying. So I would have like a notes.txt txt, yeah, so that I can use this to jot whatever gibberish that comes out of my mouth. So we have S, right? Solid principles. So we have S, which stands for S stands for single responsibility principle. Then O stands for open closed principle. L stands for Liskov substitution. Liskov substitution principle. Let me verify if we're recording. Okay, we're recording, so we're great. Liskov substitution principle. I stands for interface segregation principle. And then D stands for, so I'm just trying to use this to, kind of like as a point of reference whenever I'm talking, so that I'm not just having to repeat all this every time. But yeah, you have like a visual, like, understanding of what this is. So dependency inversion principle. So how this class would go is, I would write like a simple code, right, that kind of like violates any of those principles, right, and then I will tell you how it violates the principle, or I'll tell you to guess, so that it can be much more conversational, and I'm sure I'm carrying everyone along, right. I'll tell you to guess how a certain code violates any of those principles, right, and then when I get like your idea, I'll highlight them, and then I will tell you if you're wrong or you're right. And to be honest, it's not really a bad thing to be wrong. Yeah, definitely, because now you would get to understand why you're wrong and why you're right. And this is a very, very like conversational class, and yeah, I would love everybody's response whenever it's time to have this or ask these questions, right. So I have defined what each of these principles means, right. So when you get into an interview, it's going to be very, very easy for you to like say, hey, okay, fine, S is single responsibility principle, this is what it does, this is why you should use it, and this is how to use it, right. O is open close, blah blah blah, and then L, I, and D, that goes in for that. And yeah, so there are reasons why you should use solid principle, right, in your code, right. Like I mentioned, it's more or less like helping you view your code from a certain lens, right. So you're not just viewing your code from the lens of, oh, I have to write this code to make it work. You're viewing it from the lens of, how can I write this code to meet a certain standard, right. And the standards are maintainability, scalability, testability, also flexibility. So more or less like you're making sure your code is as maintainable as possible, as scalable as possible, right, testable as possible, flexible, and also it allows for easy collaboration with your other team members, right, because they know what to expect from you when you're writing your code in a certain way, and they know that, oh yeah, this is how you definitely are going to define you're going to define a code that does something like this, right. So yeah, so we would start with single responsibility principle, and like I mentioned, right, yeah, I'll try as much as possible to make the classes engaging. So meaning I would be asking you guys questions, and you guys would answer. The kind of application we're going to be using as a point of reference, right, is like a smart home application. So what I'm having in my head currently is, oh yeah, let's try to use a smart home application as an example. Of course, I would have loved to use like a Flutter application so that you can see it from the context of the UI or something, but to be honest, I don't have a UI, or yeah, I did not design a UI for that. So we're just going to write pure that code, and definitely this would also be as easy, right. It's just same thing, it's just you moving your that code to your Flutter code, because definitely still that you're writing in Flutter, but without any like visual feedback of what we're doing. That's the only reason why I might not be a friend of just writing just pure that. But anyways, So we have the very first principle, which is single responsibility principle, right? Which states that, a class, so we have single responsibility principle. So it states that, a class should have only one reason to change. In other words, right, a class should have a very well defined responsibility. So a class should have only one reason to change. So just one responsibility. So whenever you're building an application, right, your class should only do just one thing. So take for instance, you have your I would start. So we have single responsibility dot dart, I believe. So we have single responsibility dot dart. So let's use before we go into like the example I have in my head, right? What I can just do is let's use like maybe a simple stateful or stateless widgets class, right? So let's say we have an abstract class, stateless widgets. So this is me just mimicking like a stateless widget in Flutter. Right? So we have this, we have a stateless widget. So you have your widget, you have a certain widget that, so let's say a container widget. You have a container widget. So you have a container widget, right? A container widget that extends this stateless widget. So one thing you would not want is for this your container widget to do anything outside of your outside of just being a container, right? To have any functionality outside of being a container. So I have no certain example in my head, but I'm just trying to help you see it from the context of a widget, right? Yeah, from the context of a widget. So back to our smart home, application. I'll just clear this, right? I'll just clear this and right from our smart home application. I don't know why I'm coughing, but yeah. So we have like a smart light class. So in a smart home, you have like a smart light. Your light has properties like you can turn it off or turn it on, which we represent as variables, right? So boolean is on and then false, right? So that means it's turned off. And then we have another property for brightness. So int brightness equals to 0 since it's off, right? Then we have functionality. Of course, for a smart light, what can you do? We can toggle it either on or off. So void toggle, which kind of like just sets it to the opposite of the previous state. So just say is on equals to, we don't need to use this. So is on equals to not is on, right? So meaning if is on is true, we're setting it to false. If is on is false, you're setting it to true. And then we can just have like a simple print statement here that's kind of like that kind of like just prints like the status of that kind of like just prints the status of is on. So we can do something like light turned on and then light turned off. Right? So another thing we want to do is, right, we have two properties here. We have brightness level also. So we need like function that allows us to toggle the brightness settings, right? So, or kind of like increase the brightness level. So let's add another function that kind of like just sets the brightness. So how bright should your lights be? So set brightness as a function is fine. And then brightness level equals to just level, in which we would create a variable here. You just have to pass a variable of level here. So it is level 1 to 10, you press it in. And then also we print brightness set to level. Yeah, so we have you know, two functions. We can also look at the smart light and then look at another function we want to add, right? And say we want to, you know, save the energy usage, right? So yeah, we want to kind of like save the energy usage, store it somewhere or something, store it in a database, so you can just know you know, you can just calculate the energy usage based on the brightness, and then, you know, store it somewhere in your database. So we can have a function that represents that, which is void save energy usage, which is another function that just helps us save, that we can just use to, like, you know, store maybe in a database or something. But we will just assume this function, what these functions do is that, you know, it stores the energy data in the database. So we have usage. So if it's on, right, can just set the usage to multiply by 0.1, which is kind of like a random formula I just picked up the internet, right? So 0.1, and then we can just save to database base, which is just a print statement. So print saved energy usage. Yeah, saved energy usage, that's fine. And then we can have it as, you know, kilowatts hour. So yeah, kilowatts hour. I hope I'm correct with this. But I don't think it's the correctness we're looking out for, though. I don't think it's the correctness we're looking out for. We are trying to, like, you know, draw out a point here. So I'm writing different functions, right? I'm writing different functions. I'm toggling, I'm setting brightness, I'm saving energy usage. And then next thing is, what else do we want to do? Say we want to, you know, notify the user when, because we're already saving energy usage, we're already calculating energy usage, right? So let's say the user is using, you know, too much light, right? Or the smart light is using too much energy, and we want to notify the user that, hey, Alpha, this thing you're doing, this smart light is taking too much energy, right? And it can, you know, burn off, you know, on your NEPA bill or your PDC bill by the end of the month, or maybe I don't know, depends on how, you know, energy usage is being calculated in your area. But yes, say we want to notify the user of, you know, high energy usage, right? Then we can just create another function as usual, notify user of high usage. So all we can just do is if brightness, because we're setting the level here, right? So if brightness is greater than 80, so print print high energy usage sent to user. I don't know why these keys are. Well, anyways, so we have multiple functions, right? We have different things happening. We have toggle, we have set brightness, we have save energy usage, we have notify user of high energy usage, right? And then this our class is doing like three things, right? Number one, we are controlling the lights. Number two, we are saving that storing in the database. We're saving the energy usage data. And then number three, we're notifying the user of high usage. Of high usage. So yeah, let's go back to this, right? Single responsibility principle states that a class should have only one reason to change, meaning just one responsibility, right? So it should have only one responsibility. Can someone just look at this code and tell me what we are doing wrong and how we can improve it? Right. What we are doing wrong and how we can improve it. Just like a suggestion, there is no answer that is stupid, right? There's no answer that is wrong. There are answers that are wrong, but yeah, at least to an extent, you won't be judged for that. So yeah, I would like some. You can also type, right? Yes, this yeah. So please just look at this code and tell me what I am doing wrong and what exactly I'm doing in this code that is violating the single responsibility principle as we highlighted here, right? Because for me, I just created the class, I'm toggling, I'm setting brightness, I'm saving energy usage, and then I'm notifying user of high usage. So I am doing something wrong. Obviously I'm doing something wrong, and I highlighted what I'm doing here. So you can just look at this principle and tell me what exactly I kind of like did wrong. Or is anyone even hearing me or listening? Okay, Samuel. Okay. Okay, so we have this. Yes, Samuel.
Okay, good afternoon.
Yeah, good
Or
afternoon.
good evening, sorry. Yes, so from what I can notice, I think it's from the save energy usage, where it is saving to the database. So the database is outside the context of the smart lights, I think.
Okay, so
Yeah, the responsibility should be given to a database service or something.
all right. So you said the save energy usage is violating the rule. Okay, and then I have another one from Messi that says the save energy usage and notify of high usage is violating the rule. Any other answer? If your answer is conflicting, you can just come in, say maybe you have an idea, maybe it's set brightness or maybe it's toggle, right? I don't know. Hey, let me just give you guys like a minute if you have another answer for this, right? So by 8:37, I'll just give my own opinion or my own view. All right. So it seems no one has, another opinion or another view on this. So I'll just, continue, and I would say, the answers are very correct, right? Save energy usage is violating the rule. Save energy usage and notify user of high usage is violating the rule. And the reason for that is because, we're talking about the smart light here. We shouldn't have a functionality that doesn't in any way represent the smart light, right? Because this is out of context, right? This two are out of context. So we have this code. How do you suggest I improve this, right? Multiple suggestions can fly in. How do you suggest I improve this certain code to match the single responsibility principle and to make sure we are not violating it? Because obviously we have two functions. What should we do? Based off what this principle says, right? A class should have only one reason to change and one responsibility. How should we approach this? Any answer? It's very, very straightforward, to be honest, right? That thing that is in your mind is actually the correct answer. It's not that complicated, so I'm trying to help you guys see this from the lens of the only thing that is complicated there is the terms, right? Because someone just saw this kind of thing and then say, oh, I'm naming it something very, very long. But anyways, it's still straightforward, to be honest. Single responsibility is straightforward and it tells the story. But yes, how do I solve this? How do you suggest I solve this? Okay, so since no answer, I'll just go ahead. Okay, I think we have someone that wants to talk.
Yeah, so you can solve by creating a new class for the two function.
Okay, so creating a new class for the two functions, right? So what should we name this class if we're going to create it? Is it classes or class? Should it be, a separate class, or should it be just one class?
Actually, it can still be one class.
Okay, so create one class. So I'll do exactly what you told me to do, right? Create one class for this. So yeah. So we're creating the very first word. So what should we name the class? Yeah, that's what I'm really trying to get. What should we name this class that we're going to put these two functions in?
Energy usage.
Okay, class energy usage. Okay, we're getting somewhere. So I'll just copy and paste this, right? Okay, let me solve the problem for this one. Let's pass in like a smart light. Lights. So I'll just solve this problem for you, and I would look at this code again and see what exactly is happening. All right, so now that we are looking at this code, right, does this look completely correct? Does it follow like the single responsibility principle that we highlighted earlier? You can say yeah, it's just a yes or no answer. Let's just vote. Let me see. Just vote. You can just drop like a comment. Yes, no, yes, no, yes, no, yes, no. Okay, yes, no. Okay, nope. Maybe two more answers, and then we'll continue. So we have two yeses and two no's. So I should still be able to get two more answers, right? Maybe like a yes or no. You can look at the code again and just give like an answer. Okay, so 3 no's, 2 yeses. Okay, so for those of us that said no, right? Yeah. So what exactly should we do? You can drop like a text. I'll just read the text, right? Or you can talk if you want to talk. It's kind of like an open class. So what exactly should we do to solve the issue? So I'll just listen to whatever you say, and I'll do that. And then I'll now explain whether it is correct or wrong. Correct or wrong. One class should undo relating with the database, then other class, then the other handles the notification. Okay, so yeah, based on your, on what you just said, right? What should we name this class? So what should we name this class that we're talking about? Any suggestion? This could be, and it's not necessarily the person that gave the answer. Anybody can give like a suggestion for the class name. I'm just trying to make this as engaging as possible, so everything is not coming from my head. So notification service. Okay, fine. Right. So class notification service, and we have this. So we have the function that says this, and I put this here. So notify user of I usage. So what we have currently is it's correct to an extent, right? It's correct to an extent, though there are still some improvement, but yeah. So majorly right. The reason why we cannot have this function in the energy usage function is because we are already doing something else. We are already having like a responsibility, which is different from a responsibility of storing to database, right? Or a responsibility that has to deal with energy usage. So let's say we have a different function that does something around energy usage, then we can do that. But notifying the user of energy usage is already not a responsibility for the energy usage class we created, right? And yeah, this is just as simple as solving the issue of single responsibility in the code sample I dropped. And then so one thing we can just do in order to make this more like sane, because yeah, if you notice, the code I wrote is it's slightly funny. We can just have the function in the smart light, right? That is also kind of like a responsibility of the smart light to have is getting current usage. So we can just have like a double function, get current usage, and then can just even use an arrow function. It's nothing serious. So is on then brightness times 0.1 and then 0. This is just a function that allows us to get the current usage. Yeah, get the current usage. Is there any other thing? Let's just do something like this instead. So let's make it a getter instead of a function. So in the save energy usage function, we can simplify this by just double usage equals to what's going on 15 minutes. Wow. Double usage equals to light dot get current usage. I don't know how we're going to solve this problem of 15 minutes, but let's see. So light dot get current usage to solve our problem, and I think this is to an extent simple, and I think we solved like the issue of single responsibility. So now that you have like a baseline understanding of what single responsibility is, I don't know if anyone have a question right before we move on to the next one. So if you notice, while we are waiting on people to have questions, some of the benefits of what we've done here is we've kind of like improved how the code will be, how maintainable the code is, right? So in the sense that when a class has like a single responsibility, it's much more easier to modify, right? But imagine having all these functions here inside this, right? Even searching would be hell. So another thing is we kind of like reduced coupling. So meaning when there's kind of like a change, in this class, right? It's very, very hard for it to affect this class, right? So meaning you don't have to change something here and then come here and then change it and then come here and then change it, right? You just kind of like reduce how coupled together your code is. And then it's much more easier to test, right? It's much more easier to test. And then you can also easily reuse this code. And that's kind of like the motive, that's kind of like the vision for single responsibility, and majorly that's what we've been able to achieve here. Right, so I don't know if anyone has any question. Just a minute for question before we move to the next one. But anyways, back to our talk, right? I don't know if anyone has any question. So it seems there are two things, right? Maybe you understand too well not to ask a question, or you don't understand at all, right? You don't understand enough to ask question. But I'll just assume that's the first one. To the next, right? Open close principle. Right. So this one, it kind of like states that entities like your classes, your functions should be open for extension, right? Meaning it can be extended, but it can be extended for like a closed modification. So I'll give kind of like an example of this, and just let me just write this here. So open closed principle. So we'll just do the same thing we did earlier and see how whatever code I have defeats or violates this principle in any way. So open close principle states that a software entity, so a software entity, which can be a class, can be a function, right? Etc. should be open for extension but closed for modification, right? Extension but closed for modification. I believe. So more or less like a principle that encourages abstraction and polymorphism. So Solid is kind of like focused on object-oriented programming, by the way, right? So maybe functional, I don't know how useful this will be, but anyways, for object-oriented programming, it's much more focused on that. So anyways, back to our code. So I'll just create like a code, or write like a sample code. Tell me how wrong or how right our code is, and then what I can do to improve the code based off this principle, right? And yep, so solid principle. Then we have open closed principle. Very that. So for this, like I said, what we are trying to work on is a smart home system, right? So let's say we have like a temperature controller that can control like your AC. You can use it to adjust like your thermostat, blah 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 blah, right? Or you can just use it to adjust temperature, right? I'll just create like a simple class that represents that, and then we'll look at this class and see how we can improve it. So class temperature temperature controller. So more or less like just a simple controller class. I know a lot of us are familiar with controllers in Flutter. So yeah, this is just a simple sample. Void adjust temperature. So string device type. So let's say we have like a smart AC or a thermostat, right? So I'll just use those two examples, and we'll see how it goes. So I want to adjust the temperature. We're passing a device type, right? You know what? I'll not do what I have in my head. We're passing a device type, right? So just do like a simple if check or even switch. Let's just do switch, right? So should I do switch or if? Switch or if? Switch. I'm a fan of if, but yeah, switch sometimes is fun. Let's go with if. If device type equals to thermostat, then we can just, just as usual, print adjusting thermostat to true. We did not have like a temperature variable, so we can just have like an int to represent like our temperature value. So what the hell did I write? Temperature. Okay, not bad. Okay, so let's say device is thermostat, right? I just tend to the temperature, but in Celsius, right? Because I really don't know how Fahrenheit works, so we just stick to Celsius, and I can't find the degree on my keyboard, so I'll just use C to represent this. But there is no degree Celsius, but you all understand that I mean degree here. And then the next one is a smart AC or an AC. Else if smart AC thermostat, right? Yeah, I'm correct. So this should be smart AC and not thermostat. So we're just doing like a simple adjust temperature function, right? So say we have our smart home application, we can help this does not like ended. Okay guys, please join this call so that we can just easily switch. Wait, you can see what I'm typing. Is this still an issue? Hello everyone. Is this still an issue? Maxwell. Oh, okay then. All right, so back to our code, right? So you can just move to this other call pending. Yeah.
I can see it now.
All right. So I just turned smart AC to a certain temperature, and we can add more devices here, but my brain is kind of like blank on devices that I just temperature. I can't think of. Maybe heater. Yeah, you can do that on your own end whenever you're building or you're playing around this, right? But yeah, another one here. So what we can just do is we can create like a class that mimics a smart home application. So a class that mimics a smart home application, so that we can always like set temperature and just play with this function we just created, right? So a class smart home app. So final temperature controller. Okay, let's do this. So temperature controller, and then we have like a function that sets temperature. Can't be that bad. So set temperature, device type, then temperature, and then so controller dot adjust temperature like we add, and this is it, right? Very, very simple code, nothing too complicated. Just a smart home application that sets temperature based on whatever input you give it. So let's say the device type you're updating, you update it. Let's say it's temperature, you update it, right? So we have this simple, clean and nice code, depending on how you define clean over. Yeah, we have this simple code that looks fine. It doesn't look like anything is wrong with this, right? But yeah, I know that we have like a rule, we have like a principle, right? We have to follow. A software should be open for extension but closed for modification, right? So we have this principle. I had a notification just now. So we have this principle we have to follow, right? We have this principle we have to follow. It says should be open for extension. What does this even mean? But closed for modification, right? So just kind of like a way to add new functionality into your system without, I'm giving you like a hint, right? So add like a functionality into your system without changing what's existing, right? But yeah, we have this principle. So let's look at this code again, guys, and let's tell me what's wrong. Let's start with what is wrong based off, I know a lot of things are wrong, but based off our principle, right? Tell me what's wrong, and if it's correct too. Yeah, if the code looks fine to you, you can say that. No one is responding. Looks fine for this current principle. This current principle. Looks fine. That's the only answer I've gotten. It seems this principle, it sounds a bit tricky, but let's see. Where's my phone? Look, it sounds a bit tricky to everyone. I don't know why, but I think I understand, because it's reading it just sounds a bit complicated. A software entity should be open for extension but closed for modification. Right. So take for instance, I mentioned something. I was saying, let's say I want to add a device. Let's say I want to add a new device to this code, right? What am I going to do? Guys, right? So you have to answer this one. All right. So yeah, I almost missed this. Anyways, I'll share my screen again and we can continue. So back to our code, right? It seems the only answer I got was that it looks fine for the current principle. But I'll just ask like a question, and I want quite some people to answer. So let's say I mentioned ether, which is another device, right? Let's say I want to add ether so that I can be able to adjust the temperature, right? What exactly am I going to do? What exactly am I going to do to this code I have here? Hello. I'm not hearing anything. Wow, can you guys hear me?
Yes, I don't understand the question.
Oh, okay. So for instance, now we have two devices here. we have two devices here that we can adjust temperature for. So you have your what we're building, right, is a smart home system, a simple smart home system, but we are representing this with code. So let's say we want to add a new device to this our controller, right? How do we do it? So let's say we want to add a new device. So we have our first device, which is a thermostat, right? And then we have our second device, which is a smart AC. We have our second device, which is a smart AC. Say I want to add a heater to this. How do I approach this? How do I do this?
You will extend the else if statements. You add another else if statement.
Oh, okay. Else if.
For this kind of device, if you want to represent this kind of in that, it's best to use an enum.
Oh, enum, right?
Because of,
yeah, I was hoping
yes,
I was
because of-
hoping someone spots that, right? I wanted to change it earlier ago. I was hoping someone spot that, and yeah, since you spotted it, that's fine. So enum, device type, and we have thermostat. We have thermostat. We have smart AC, and then we have the third one, right? So if we want to add heater, we have heater. So device type equals to thermostat, right? Device type does thermostat, blah blah blah. Or this is where if statement comes into play, you just switch device type. I think this should just automatically add this, right? So we have this, print this, right? Print this. So we have another one. We have another case. Just add the missing cases, right? And just print smart AC, and then the final one. And the final one is heater. So the final one is heater. Give me like a minute. Let me plug my PC. And while you guys look at what I just did and try to figure out why this is wrong. So take a look at our rule again. Take a look at this rule and say that says a software entity should be open for extension but closed for modification, right? So if you notice what we're doing, we are already modifying. So just look through. Yeah, so guys, I hope you're already seeing like the picture, right? So let's say we want to add another device again. What device can we control the temperature? What device can we control the temperature? Looking at this house, what temperature do I control here? Thermostat, smart AC, heater. What else? To be honest, you can say refrigerator, right? So you can just add, right? So if we want to add, right, we are coming here, we're adding refrigerator, right, which is not bad per se. Refrigerator. Or just simple fridge. So we're adding a fridge, and then we can control the temperature, right? Adjusting fridge temperature. Okay, so we have this. So can you guys see what is wrong already? So go back to this code that says a software entity should be open for extension but closed for modification. So who says what's wrong? Okay. Okay, so one thing I don't understand. Let's start with the first one. I think I missed everything. Okay, so it no longer conforms to the open close principle. It's wrong because for every device type we have to modify the if else statement 100%. Okay, fine. So it's wrong because for every we have to modify the if else statement. Okay, then one thing I don't understand is whether the temp controller is a property of the classes we created or the smart appliances are a type of temp controller. So temp controller is a controller, right? It's a controller class. The way your text form field and your text editing controller, they are different, right? So it's just kind of like a controller for your smart home app, right? Yeah, for a smart home app. So let's say we have another controller that has to do with water controller. To be honest, I'm blank on ideas, but we have another controller that is water controller, right? Say you want to control the level, the inflow of water into your smart home application, right? So you can have a controller that just does whatever we need to do, right? So it's just like a controller for our smart home application. So we can have different controllers. That's just like the context, but because I defined it as just controller, maybe that's the reason why it's confusing. But this is just our temperature controller, and this. So let's just remove this. Back to this, right? So this approach is wrong. This approach is wrong because every additional device will cause a change to the temperature, blah blah blah. To the temperature controller, it's best to create an abstract class that houses each device implementation, so the temperature controller can easily be extended rather than modified. So we should have an abstract class that can be extended for different device types. So I just inherit the property. I think we're getting somewhere. So you guys can see like the picture already, right? You can see the picture and how problematic this is, right? So in order to solve this, okay, so let me see if I can follow you guys' approach here. Abstract class that houses each device. So to be clear, right, when you say abstract class that houses each device, what do you mean? So do you mean this? So abstract class. Do you mean this abstract class each device thermostat? And then abstract class smart AC. Then abstract class heater, right? Is this what you mean? Favor. No. Okay, so can you just kind of like help with like a definition? So I'm just trying to be clear, right? So I'm sure that we are on like the same page and I'm not just acting based on my instincts. Okay, yeah, that can work. Nah. This won't work. All right. So I'm trying to look at it. I'm trying to look at this, right? Because when something is abstract, right? How can I define abstract for you? So abstract is something that that is not directly an implementation of something, but is more of a representation of what something can be. So let's say we have I'm blank on examples, right? On real world examples for abstract class. Abstract classes, right? So abstract classes, okay, yeah. So abstract classes, right, is more of a painting. So say you have like, someone, say you have like, a painting, someone paints like what, or no, kind of like an architecture, let me put it that way. So architecture design, right, on paper is not exactly the implementation of that design, right? It's just a representation of what, of what that house or whatever is in the design can be, right? It's not exactly the design. So abstract classes are representations and not implementations, right? So yeah, I was just trying to clear this up, and thank God you mentioned that, right? So this won't work because we can having 3 abstraction for same device, right? For for a device that has like the same functionality, right? I really don't see the picture. So what we can do, right, is I think you guys understand the problem, right? But the issue is solving it. So maybe the temperature controller class should be abstract interface, while each device should be a class that implements it. I want to really go with that. I want us to really experiment this, but I'm not sure of my battery, and I think there is an issue with my light, so I'm not sure. I want to really experiment this and see like the picture of what this means, right? So the temperature controller class should be abstract interface, while each device will be a class that implements it. Temperature controller. So the controller cannot be abstract. Because the controller is kind of like an implementation, right? We don't have multiple we don't have multiple implementations of like a controller. The controller is just one class, so it cannot be abstract. Let me just explain that. So Mercy, you say you don't understand what the problem is. So how do we drift back? So let's look at this code again, right? I would explain so that I'm sure I really need to. That's the reason why I love like this small class, right? So I'm sure even if we stop at just open close principle today, I'm fine with that, right? And I'm sure that everyone, okay, we might not stop at that. I think it's okay. We might not stop at that if this light problem is fixed. So let's see. Let me try to paint the picture or the problem again, right? So take for instance, we have this temperature controller, right? We have this temperature controller, and then we have our adjust temperature function. So let's say we want to add another device to this temperature, to another device that would like to adjust, right? Let's say we have another device that would like to adjust. Let me take this off. Right. Let's say we have another device that would like to adjust. How do we add it to this? So in order for us to add this, let me just, so I don't ask too many questions, right? In order for us to add it, right, we just come here, we had the new device. We had a new device. Right? And then we come to our temperature controller, and then we adjust this. We adjust this by having a case device type dot new device. Like I mentioned, I'm just blank on the example, so just roll with whatever I have. So the problem here now is this is going against what open closed principle should be, right? So if you look at what open closed principle state, it says a software entity should be open for extension but closed for notification, right? Well, if you look at this, our class, we are just coming here whenever we need to have like a new device type. We just come here, we update this, and then we say a new device, right? New device, add new device. We say add this new device, right? Which is a problem. Because let's say we have multiple of these, we have multiple of this, right? We just come here and then we keep having, we keep having new cases, right? And then this just becomes hell to manage, right? Say, because let's say I want to add like a custom functionality to something. I'll now start looking through like your line of code just to make changes, which is going to be a problem. I'll just shift back. Let's take our code back to like the previous state. I don't know if you understand already. Messi, just confirm that you understand before I move to like the solution, or I can see an answer here that sounds a bit convincing. Oh yeah, you understand now. Okay, what if we have a device abstract class that defines the methods and properties a device should have? Then every device type extends or maybe implements it. Okay, I think we're getting somewhere. So abstract class, right? Abstract class, and then we have like a temperature device, right? Abstract class temperature device. And so okay, so what's the do say again? That defines the method and property the device should have. Okay, to be honest, right, there's only one function here. There's only one function that takes it. Okay, just now we might not just need to parse in the device type. Okay, let's just let me try to picture the example you're giving. So we have void adjust temperature, void adjust temperature that takes in a variable temperature, right? So we have this abstract class. So according to what is suggested, right, each device type should implement this. So class, our very first one is thermostat, implement temperature device. So create one missing override, blah blah. Just do the same thing we're doing here. Print thermostat. Wait, so that I'm sure, right? Toasting, is this what you mean? Or I am jumping? Wait, I don't think this is our moment. Oh yeah, maybe it was just glitching. Anyways, yes, that's what you mean. Okay, fine. Right, I'll just continue with this. So we have another class, smartacy, right? That just implements temperature device, and let's just duplicate this, then iter, and then fridge, and then fridge. Create one missing override. Blah blah. Smartacy, adjusting smartacy. That's all we just need here. Adjusting smartacy. Create one missing override. Adjusting iter. Adjusting fridge. Right. So temperature controller, smart home app. Let's comment out this for now and let's focus on what we just did. So I'll move this down so that we can just start from the top. Right. I'll move this down so we can start from the top. Yeah. So just to be clear, this is what you mean, right? Okay. Yeah, you said that already. So we have an abstract class that defines, temperature device, right? Then we have thermostat. Then we have smart AC. We have iter, right? We have fridge. So if we want to define a controller for this, how we can do this is we have class. What's the name of our controller again? Temperature controller. Okay, same temperature controller, and then we have a temperature controller. What does our temperature controller do? You just adjust temperature, adjust temperature, adjust temperature, and yeah. So what are we parsing in? Okay, yeah, you guys, let's define what our new temperature controller would look like. So what am I parsing into this adjust temperature? Tossing, anyone can answer that? Like, it's just straightforward. What am I parsing? Am I coming here to still parse device type, or exactly am I passing into this temperature so that we can just, you know, so what? It's no one answering, right? So what am I passing in? So I want to print, right? Or I want to just I want to adjust the temperature. We have this classes that have been implemented already, right? I want to adjust temperature. What should I pass here to be able to call these functions that we have? Do I now start parsing? Let's do it. Let me do this right. Do I start parsing iter? Maybe we can make it nullable, right? Do I start parsing iter so that, oh yes, if iter if now I don't even know how this is going to work, but yeah, so should give me what should come in. Just the temperature should to be adjusted. Something sounded just now. I hope it's not timing, but anyways, just the temperature that it needs to be adjusted, right? Okay, let's try this. Let me look at it from this perspective. So int temperature. So how do I adjust the temperature? Okay, you can do fine.
Sorry.
Okay.
Okay, so I think I got that wrong at first. So you said how do we adjust the temperature in the temperature controller? So we are in need of the temperature device, right?
Yeah, we are in need of the temperature device.
So I don't know. I'm guessing we can just call we can just create, I don't know what's called, of this temperature device, and I think from there we should be able to get that stuff.
To be honest, right, it might not be done, right? What did you say I should create? Is it constructor or I should parse in like a temperature device?
What I'm not sure of is if I want the temperature controller to be in charge of the device, the current device that is being selected.
So the temperature controller should not, the thing with this, right, is the temperature controller should not be in charge of the device that is being selected, because the reason for this is because meaning when you're using it in your application class app, sorry, I can't remember the name of the previous class we had, but yeah, when you're using it for your application, you have to now define multiple controllers, right? So temperature controller equals to temperature controller, and then you parse in what type of device, right? Fridge. You just do the same for this, and you're having multiple controllers, which shouldn't be the case. So the class should not be, in this case, right, the class should not be like, in charge. So how do I call this function as a question, right? You can do final temperature. So this is same thing I'm talking about, right? If we do this, right, and I'm just passing it through the constructor like I mentioned, temperature device, you're right, it's going to work, but I think we are creating another problem for ourselves, and then we just create a constructor, and so let's ignore this. So what should we do here? To be honest, it's straightforward, right? Tosin.
Okay, so what if adjust temperature takes in a temperature device?
Okay. Yeah, temperature device, right? Device. And yeah. So we have temperature device. Then all we just have to do is call device dot adjust temperature, right? And we're adjusting temperature. So okay, fine, we have this already in place. Okay, Samuel.
Okay, so looking through everything, I'm just wondering, since we are trying to make the temperature controller, since we are trying to make it sort of independent of whatever application it is going to be used in, can't the the temperature controller rather, can the temperature controller just adjust the temperature, like just adjust the int value of the temperature, and then each classes would decide how they want to notify the user, or how they want to notify that the temperature has been adjusted, like the print statement that we are using in adjust temperature. Can't the print statement be moved to the class? I don't know if you understand what I mean.
Okay, move to this temperature controller, right? Yeah, you know this,
like the temperature controller.
Okay. Yeah, just come again.
I said the temperature controller.
Yeah.
I'm not even seeing this properly. The temperature controller.
Mm-hmm. You wanted to do this.
I'm sorry. I think I need.
Okay.
No, just continue. I don't think I've seen what I saw.
Okay, so I think what you wanted us to do was move this to this place and move this to this place and move that to this place. Then we are back to this issue again. Then whenever we need to change something, we are adjusting it from here. So anyways, adjust temperature, device dot adjust temperature. I think we are fine. Then let's go back to creating to what mimics our smart home application, right? And try to use the controller here. So smart home app. Okay, smart home app. Yeah, that's correct. Then we have a final temperature controller, or controller, it is still equals to temperature controller. And then we have this. Then we have a void set temperature. So I think it's void set temperature. Yeah, void set temperature. And okay. Set temperature, and then we can have we can just have same thing that was called temperature device, and temperature can just pass it here. Just press it here, and then we can just based off the controller then adjust the temperature and this. Set temperature, adjust thermostat. I think we're fine. Fine. So yeah. So if we look at this, right, let's look at this and compare it to our previous implementation. So you'd see how problematic this implementation is, or how it's problematic it can get for you as a developer or for a team of developers, right? Because having this, just having case blah blah blah, case this, case that, case this, case that, you can have a very, very long list. But this one is way more easier to to just add a new device, right? So let's say the new device that I want to add is a smart fan. Just the simple class smart fan, and then it implements temperature device, right? It implements temperature device, and same thing, override override, and then we can just print smart fan. So we have all these. We have this temperature device, smart fan implementation. So it's very easy. It's very easy to add more devices without blowing up the code or racking your brain. So another interesting thing is how we don't have to start adding check. Yeah, because we've abstracted this, right? We don't have to start adding unnecessary checks. Meaning, say we want to use our smart home application in a real application, right? We have void main, then we have smart home app, right, equals to smart home app. So smart home app dot set temperature. So you see how we don't, whenever you can pick any of the devices you've created, right, and just do this. You can pick any of the devices you've created and just say, hey, smart fan I want to press in, right? So smart fan, and then temperature is 3, and be it, you can easily add any of the devices that implements our temperature device, right? So it could be our heater, and it's just that easy, right? So we don't complicate this, and it's kind of like makes it much more easier to maintain, and then you're reducing. To be honest, we are using 12 hours already. I kind of like foresaw this. I knew that there are chances we might not be able to. 2 hours might not be enough for this. Let's see how far we can go. Anyways, so we can see how easy it is, how you don't need to complicate your whole product, right, or your whole project to write code, and it's much more readable, it's much more testable. You can add features for smart fan, you can add features for thermostat here, maybe, and then you can use it to adjust the temperature. So let's say you want to use like the size equals to that. This is wrong. This might not be how you want to approach it, but so let's say you want to use like the size to adjust temperature. So let's say if size is greater than 20, right, you want to adjust it in a certain way, you can do it, right, without it affecting this. So that's just that's just how it works. So you're reducing risks, you have been more flexible. It's very easy to scale, meaning you can add more over time, and you find, and yeah, majorly that's it. Okay, so does anyone have any question? But for me, I believe the class is getting too long to operate. If everyone is still fine to continue, then that's okay. Yeah, does anyone have a question? I can't see your current changes. Wait, this is 2135. Which changes are you talking about? I deleted a lot of things, right? If that's what you're looking at, I just removed it. I removed a lot of all those things and just left this, right? So maybe that's the reason why you're not seeing them. I'll just clear this also. And this is the new code we have. Yeah. So Liskov substitution, interface segregation, dependency, inversion. Okay, so yeah. So Liskov substitution. I'm trying to make up my mind if we should. How many minutes have we used? Okay, so we've used 1 hour 25 minutes. So guys, should we set the remaining 3 or the zip of the code? I'll just push this to GitHub. Yeah, here's my GitHub. It's been a while I pushed to GitHub, so maybe this will just. Let's play solid tutorial. Public. Getting it. So I'll just do this, and or something like that, and then single responsibility. Implementation. Open closed. So you know what? I think we'd have to reschedule this class, the rest of this class for another time. So what you can do is you can what I'll do is I'll kind of like I'll get like some questions or like some code samples, right? And you guys would detail how this defeats our single responsibility principle, and how it defeats our how it violates, that's right word, our open closed principle. Then we can go into Liskov substitution, interface segregation, and then dependency inversion another day. But I was thinking tomorrow, but I don't think tomorrow is feasible because there is going to be a space, and yeah, so maybe like Wednesday or something. But yeah, hard single responsibility implement now. Open closed. Then notes. Class notes. Yeah. So what has it been a while since I pushed to GitHub? For me, I've just been vibing with my life. I've not been really serious with tech like that, bro. Also, what I've been working on does not really require because it's not being reviewed by anyone. So it's sometimes pointless. Sometimes the only reason why I should store it on GitHub is maybe just to reduce risk, and that's it. But yeah. Anyways, I would push soon. I'll push like a real product soon, but I'm just working in the background for now. Yeah, so that's the link to the GitHub. I don't know if I introduced myself earlier, but I believe maybe everyone should have kind of like a baseline idea, but maybe next class I'll do like a proper introduction. That should be it from my end. I don't know if anyone has any question. Does anyone have any question, suggestion, anything? Right. Hello. So
yeah, I don't have any question.
Okay, then great. So I shared the GitHub already. Well, what I'll just do is I'll try to remember to share the Mercy can remind me. So yeah, so at least by tomorrow you should have like a sample code that you guys can just use to practice, or it can be multiple codes, right? It depends. It's based off vibes. But anyways, that's it from my hand. Thank you very much for joining the class. Over to you, Mercy.
So thank you so much, Sister. Thank you so much. This is really a lot. Now we have a little bit of understanding of this whole principle and all. So as I said, we continue the class on Wednesday, and then I will remind them to drop the codes. Instead wants to the questions on the ones we've done. So maybe by tomorrow you can just practice it, and if you have any questions, you can drop it in the group chat.
Yeah, and most likely this video might upload it to YouTube. So I'll send this video to a proper video editor. Maybe he can look at, maybe there is a way we can make it much more professional, and I'm not even sure what the result would look like, but I hope it's great. If it's great, right, we can just send this off to YouTube also, and so you can have access to the video again, right? So anytime you want to just check it out, and yeah, that should be it. See you on Wednesday.